Hi, everyone. Please, at the beginning, a show of hands. So who is running production on Kubernetes in this room? Great. I want to talk to all of you guys later. I have so many questions. Okay, so what do I want to talk about today? Basically, I want to give a short overview of Infobip platform, what it is, what problem does it solve in terms of business, and then take a sneak peek in the background, what is actually under the hood of this thing, and also discuss some of the challenges that we cross almost every day and why we are thinking about going into Kubernetes world instead of doing things like we are doing it now. Also, at the end, I would like to show you maybe a few examples, of the stuff we did and where we are kind of taking it next after that. So, how many of you have heard about Infobip before this lecture? Okay, so half of you probably work in Infobip, and the rest, I don't know where you heard it. So, it's interesting because today, for example, I got an SMS from my bank about Black Friday, which is tomorrow, and some sales discounts, and all of this. And maybe you probably did too. And this message was delivered to me through Infobip platform. So Infobip platform is basically a communication platform as a service. And what we do is we enable businesses to reach their customers through one single API, through one portal, in an easy way, right? And in terms of our company, so we have offices all over the world, across almost all continents. Probably Antarctica is the only one that is missing. And we are running our platform on more than 15 locations. And you will see a lot of those pluses in today's presentations because these numbers change, from month to month. And really, whenever I say a number, it's always too low number. So we have over 2,000 employees currently, and this makes Infobip one of the largest in the industry, largest the companies in the industry. So what does it mean, communication platform as a service, right? So on one end, we have the enterprises, right? The businesses that wish to communicate. And the businesses wish to communicate with their customers, right? Through mobile phone applications. In the middle, we have the Infobip platform, which has all of these nice features of high availability, ease of use, geo-redundancy, smart routing, and so on. And at first, it was just SMS. Right? So first SMS was sent like 1992, right? And Infobip sent its first SMS like 15 years later. And today it's not just SMS, it's more and more of these other channels coming into play, right? So if you ever got a call from Uber, if you ever got a message from Viber, chances are these messages and these calls reached you over Infobip platform, which is kind of cool. So on the other side, for the businesses, we started to provide more added value services. It's not just calling API to send a message. It's like conversations with your users, sending smart campaigns, smart questionnaires. So at the heart of it is what we call Infobip platform, right? And like 11 years ago, when I joined the company, it was really simple. Like one application, and I kid you not, one server, and it knew just how to send SMS. So it was really beautiful to work in this simple environment, trust me. So today we have like almost 1,000 applications running on our platform, providing different features of this platform. And these applications are developed by like more than 50 teams. Like this is the latest number, right? It will probably go up. And what we have is that over time we saw that deploys of changes to our applications in production started to happen more and more often. Currently, when we look at our platform, every minute some change is deployed in the platform. All of this is running, across 15 locations on top of 8,000 virtual machines on top of 600 physical machines, and unfortunately, we must manage all of that ourselves. So this platform evolved through the years, and I was happy and I was lucky to witness this evolution, and how it went. Most of the stuff inside this platform I contributed on, and like most of stuff that broke, I also contributed on. So there were like two key points in this history that kind of started this evolution and this like hyper growth, right, of our platform. One was when we started to split this, huge monolith into more manageable chunks. Like later we learned that, this is called microservices, but it's not like we planned for it, right? Or that we knew what we were doing. It was just a problem for us because we had more developers, more features, and one code base, and it was really tough to manage it. So we started trying to split logical pieces out of it so that these teams can work on those parts themselves. The other was introduction of Docker as our kind of standard packaging of applications. Why? Because if you have Docker images, you can package whatever is inside, right, and just deploy it in a standard way. So this was kind of the point. And in terms of what stacks we use, we have everything, right? We have, mostly it's Java, we have .NET, we have Node.js, we have Python, whatever kind of comes cool next, we probably have it, right? And packaging in Docker kind of helps us really solve this problem. I don't care what it is, just Docker run, right? So when we look at our platform today, like from high above, you will see something like this, like lots of green squares. Greens means good, like red means bad. So it's good, kind of, at least on this screenshot, right? So all these squares represent, every square is a single application. And these green circles or dots, purple, yellow, they represent actual instances of applications which are running on our virtual machines. So somewhere, early on, we realized that we need to kind of streamline service deployment. We needed to make sure that the developers can deploy stuff in production in an easy and a safe manner. How does this look? And this is actually what every developer in Infobip does the first day they come in, right? So we give them a task, and it's kind of for warming up and for learning the infrastructure. So usually we write code, we also write tests. We write tests because we want to sleep at night, right? So this is why we write tests. So after that, we build a Docker image. This is all in some kind of CI pipeline. Then developer deploys this to pre-production, does whatever manual tests are required. Then potentially you need to create some virtual machines where your application will run. Usually you already have them. And then you deploy this to production. And what you get is, something that looks like this. Like application is on top, it sits inside some Docker container, which is run inside the operating system, which kind of lives inside virtual machine, which kind of lives inside the hypervisor, which lives on physical machine, right? And what we would like to do is for our developers and product teams to focus more on the green part and forget about this underlying infrastructure. So during this time, we kind of developed lots of these internal tools that we needed to make it easy for developers to deploy stuff to production, right? So when I switch teams, I don't want to learn, how they do it, right? This is very bad for productivity. At least this was our experience. So what we did some tools. So we built some deployment manager applications where you can, see your instances, you can check out their logs, you can move them, you can remove the traffic processing from those instances. We created tools that facilitate creating of virtual machines so that we don't have to create tasks for our ops team to create virtual machine when I need it. So we created some deployment pipelines where it is very easy for developers to simply choose to which locations they want to deploy their applications. We put everything in Jenkins with some checks that make sure that when you deploy the application, it's actually safe and that we are pretty sure that it will work and something will not break. So we do some canary tests, some smoke tests before we actually put the traffic, processing, actual production traffic processing to this deployed instance. And we do all of this like in parallel, every data center does the same thing. And also, we needed to build a lot of other tools, for security, for public API management, for RPC, like inter-process communication, how services will connect to each other, how they will talk, how they will discover each other. So it's kind of, we are building all of this stuff just to be able to do business, right? So this underlying infrastructure is very cool because now you have some, kind of unique way of doing things. When you make some positive change, you affect everybody, also when you make a negative one. So this is all cool, but the price you need to pay is like this overhead of management of all of this stuff. So these are kind of our challenges currently, right? So first, you need to have people that keep this machine running. This platform needs to be running 24/7. We are currently having like SLA of 99.9%, which actually means like 40 minutes downtime per month, and we are aiming to have only 4 minutes downtime per month. So obviously we need to improve it because we don't have something that is perfect. Always it needs some kind of improvement. And like the maybe most difficult part is to onboard new people to help because you need to teach them all of this stuff that you have, which maybe is there from some legacy reasons or whatever. We have, like, on top of that, we have more challenges, right? We have own hardware, we need to put it in those locations. We have lots of those locations, and we need to build more, right? And the reasons for that are simple. They are business reasons, right? You need to have some presence, some low latency API, and you need to put it close to the customer. So these are the reasons kind of that drive us to make our own data centers, although we would rather not do it this way, right? But sometimes you don't really have a choice. Also, on some locations, we are leveraging the public cloud. So we are trying to use their infrastructure, their resources, to basically increase our processing capacity. So this adds more complexity because now we need to, here we need to connect AWS to us, here we need to connect Azure to us and kind of use their resources. So at some point we started to ask this question, like, can we do all of this and more, but with less effort, right? And this kind of made us think about switching to Kubernetes as our platform. Because when we took a look under the hood, we saw that Kubernetes is not doing really much different stuff than we are trying to do. It just does Docker run under the hood, right? With some, cream on top of it, sure. And we did consider other, orchestration engines, right? And the question on everybody's mind was, but this is, and we heard it also today on some other presentations, like Kubernetes has lots of moving parts, and you need to be able to manage it. You need to have the know-how. This is the real challenge when you want to run Kubernetes on premise. And the question is, can we do it? Do we have the people that can do it? How fast can we have this knowledge, right? So, what were the benefits that we were kind of looking for when, switching to whatever? We chose Kubernetes because, it's kind of the leading industry standard in orchestration systems. We also looked at Nomad from HashiCorp. We also looked at Mesos. We also looked for Docker Swarm. But kind of, the Kubernetes seemed the most mature and most fitted, our use cases and where we wanted to be. So, like, what we expect to get is better usage by, leveraging the containers by Kubernetes. We can pack more tightly our applications together, and instead of having these heavyweight virtual machines running our software, we can just run maybe more tightly, more densely containers which are running on top of some whatever, right? So we also were looking for easier third-party application installation. Our tools were always kind of centered on, our services, and they're not really suited. It's very tedious, to deploy some third-party application through our tools, and then we need to invent ways how to do it, and it usually ends up having 10 different ways, which are kind of the standard way of doing it. Also, what we wanted to have is like a stable platform. We also have APIs how to do it, how we communicate to our platform, but we're not really good at documentation. right? So it is very easy when you get a new person to help, to show him, we are using Kubernetes, here is the documentation, so a person can do a lot of it, by themselves, right? And what we are aiming for is this infrastructure abstraction. So basically, stop thinking about virtual machines, because now we are, right? Now I know where my virtual machines are. I know I need to create them. I know, we are using pets, right? And pets are, for us, pets are good. Pets bring money, right? So as long as pets bring money, you take care of your pets, right? But we would like to maybe, stop thinking, is it possible to stop thinking about pets and simply, think about applications and say, I want to have 6 of those applications running and not to have to think about where and how. So in essence, what we would like to focus more on is business, right? And less infrastructure, but not to lose, this engineering culture that we have, which actually, is the reason that we have all of this business running in the first place. So when we started to see how to, how do you go about trying out Kubernetes? So ideally, we would like to fail fast. So ideally, at the end of the week, I would be able to say Kubernetes is not for us, or yes, Kubernetes is, the right way to go for us, right? And what we ended up doing is kind of trying to do this fly or die MVP or POC, however you want to call it, right? So the point was, okay, what are the questions that we need to get some answers to in order to be able to say, yes, Kubernetes is the right choice, or no, let's try something else. So first thing is like cluster management. So how do we even create those clusters? How do we upgrade those clusters? How does this work, right? Next big questions for us is network connectivity. How do we talk, to our existing infrastructure from Kubernetes and vice versa? Another big thing is the storage. So we have lots of applications which are stateless, but we also have applications which have some state. And I'm not talking about databases. We have those also. I'm talking about applications which create state somewhere because they can. They have virtual machine. Virtual machine has disk, and they just put state there, and it's their virtual machine. And how do we handle that? How do we handle security? We know how we handle security now with access to virtual machines, but how does this look in Kubernetes land? And in the end, does it really help, our developers to be more productive, or is it just some another, level of abstraction which will bring only more questions and zero solutions, right? So what we ended up is this. For cluster management, we kind of put all the configuration on one repository, like we keep it in Git. Then we use our existing tools to provision virtual machines on top of which we will install this Kubernetes cluster. So our standard setup is to get like 3 masters, 3 worker nodes, and 3 some nodes where we will store our network block storage, right, for disk. And after that, we use like open source tools, KubeSpray and Ansible, to simply sprinkle, Kubernetes on top of these machines and have a Kubernetes cluster running. So this is kind of the first step. It's not a big cluster. It cannot handle lots of workload, but it is good enough that we can put it on every our location, and start using it. And then as we, migrate step by step our workloads to Kubernetes, we can increase the resources, right? So all of this takes under 1 hour. So we have been able to deploy new clusters like under 1 hour when we need it. Also, the question for us is how do we, evolve those clusters? I need to apply some other configuration changes. How do I propagate those configuration changes to all the clusters? And here, there are open source tools available. We are using Flux, which kind of, what happens is you put a configuration change, you commit it to Git, right? You push it to Git, and in every cluster you have this Flux operator, which is actually a piece of software. It just monitors this repository, pulls in this change and applies it, just as I would apply it manually, right? And after that, we ask ourselves, okay, but how are we sure that our 15 clusters actually have those configurations applied, in a way we want? And the answer to this is we use tests. We write tests which we can hook to Jenkins and basically run whenever there is some change, or nightly, or wherever. And we do it in Bash, right? It's very cool. I don't know if you have ever written test in Bash. It's very cool. I like it more than Java. Okay, next thing is like network connectivity. What is fully important to us is to have transparent network communications. Ideally, I do not want to know that this application is running in Kubernetes and have some weird stuff like load balancers in front of them having to be configured, because we don't have anything like this now. So what we ended up with is this. So when I have a standard infobip like virtual machine and we run some application inside the container, this application starts up and listens on some port. And what happens on Kubernetes worker node when we deploy an application is, its container is also started. But first, it's the pod is created. This is this kind of collection of containers that Kubernetes kind of calls pods, right? And every pod gets a specific IP. And this IP is some specific range which doesn't have anything to do with our infrastructure. And the application starts up and it listens on this IP and everything looks good. We have the connectivity between virtual machines. So packets know how to get from one virtual machine to another because this is our virtual machines, our infrastructure, our routers know how to handle it. But when we are sending packets to these strange pod IPs, nothing works, right? Because routers do not know anything about those range. So what we did is we used Calico networking plugin for Kubernetes, which uses BGP. And we heard on the last lecture, like BGP is the protocol which kind of makes the internet work, right? And what happens is this. So while our application work, when we start an application on Kubernetes worker node, the pod is created, right? And the pod gets its own IP. And now what Calico does for us is it just tells our routers, look, when you want to send packets to this strange IP, just send it to this virtual machine, right? And the application starts, and now my packets know how to reach this application. And this is super important for us because these pods actually becomes, just another virtual machine with their own IP, just like we are having it now. And this whole pod and service IP range, which is specific to Kubernetes, to every Kubernetes cluster, just becomes another subnet that we are routing on. And all of this stuff that we have developed previously, like DNS, service discovery, inter-process communication, monitoring it just works because you're just targeting some IP, and the packets can go in and out of this IP. So in terms of security, we didn't really, do much. We don't have like clear reasons to do it this way or some other way. But what we chose is to create some Kubernetes namespace per service, right? And then just let the teams which own those services be also administrators of this namespace. So inside this namespace, they can do whatever they want. They cannot do anything in some other team's namespace, just like they are currently, admins of their own virtual machines. We also introduced some resource quotas so that we kind of are sure that we don't overstep our resources that we have on the clusters. And one important thing is, like what we are using to authenticate users to our clusters is token-based authentication. And when we first started to investigate, okay, how do we now, when some user wants to perform some action on Kubernetes, how will Kubernetes know if this user is allowed to or not, right? And when we started to investigate, there are some complicated setups. What we ended up with is a very simple setup in Kubernetes, which actually allows you to tell Kubernetes, look, I will send you this token inside HTTP header. And when you get it, please ask some external service, which user it is and which groups does it belong to. And after that, Kubernetes knows how to apply roles to this user. And for our developers, it is very easy to set up. We already have such a key, and we use it across our platform. Developers use it, so we just reused it here. And it is very easy to set up and to use. Storage is like a big question mark for us, right? And we have applications that use file shares, and this actually works pretty good. This really works. We are using Microsoft driver for this, which they use for Azure Cloud, and this really works well. And we installed this Ceph, but we really don't know much about Ceph. So if Ceph breaks, it's a problem for us. And we installed it in our clusters by default, just to have some kind of network storage, right? And we are hoping to learn more about it as we go. And why do we install it? I would rather not to have it, right? But I would rather have storages that we already use, but the problem is not in every data center we have this expensive IBM storage area network that we can use. We hooked it up where we have it, so there we can use it. Also, we are trying to use local disks of these these worker nodes in Kubernetes, right? Because this is how actually our applications are working now. And the downside is that once the Kubernetes schedules some application to work on node, and it is aware that you are storing state on this node, it will not be able to reschedule it somewhere else, because you would lose state. But we are willing to accept this at least in the start until we solve this network storage part. So how about developer productivity? So I have like 2 use cases that I would like to quickly cover with you. So first case is like installing Redis. So how does it work now when we do it on our platform? We create a virtual machine, we start Redis process on top of it. We create another virtual machine, we start another Redis process because we want to have 1 master and 1 slave. Then we add 3 more virtual machines when we install Sentinel processes on these machines. We connect Sentinels to Redis processes, and now we have a cluster. In the end, we connect application to Sentinels, so now application knows which is the master, which is the slave, it can get the data, right? And this process is not hard. We kind of automated a bit of this, but the problem is, it's custom built, right? It's something that we wrote, we need to maintain, we need to onboard new people, we need to explain, we need to add more stuff. Just adding Prometheus metrics exporter to this setup, you need to go in there and do it, right? So could it be simpler? Right? How would it look on Kubernetes? And it actually looks like this. It is just 1 single command to create a cluster, right? And what happens is, one Kubernetes just sees, okay, he wants a cluster. There is some manifest describing how it should look like, and what should happen. And what happens under the hood, this pod is created. It has all the necessary process running inside. 2 more are created, so we have 1 master and two slaves. Sentinels are automatically configured, and we just connect the application. On top of that, we put a small user interface which kind of helps developers to feel like they are using the same tooling, right, that they use now, which is super easy to simply execute this command. Under the hood, Jenkins executes this command and deploys, to multiple data centers this cluster. So, and in terms of code, it is very easy to use this. You don't need to have any kind of magic to discover your services. You just use simple DNS discovery. So this first part is always the same. Whatever, when you deploy a service, it gets a stable DNS name inside the Kubernetes. And what changes is just where is our location, where are we running it. And then we do a simple DNS service lookup, which kind of returns the IPs of Sentinels and where they are listening on, right? And then we can use this to decide if we want to connect to this cluster or fall back to whatever we are using now. This is the actual code we use to fall back. If we don't have a Kubernetes cluster on premise, we will just fall back to, try to fall back to standard deployment of Redis. And because our networking is solved, it is very easy to hook it up to our monitoring. We export all the application metrics to Prometheus, and we scrape them, and we use Grafana for monitoring and drawing these nice graphs, and also later for alerting. So this all just works. So another use case that I would just quickly like to brush through is, how do we enable sending WhatsApp messages, to our clients? So what you need to do is you need to take this appliance from Facebook for WhatsApp, and you need to install it on premise, right? So this part is not our code. Anybody can do this, right? And this is the architecture of this solution, right? So you have some containers, you have some load balancer in front of it, right? And this is like an appliance. Think of it as an appliance. So, and you don't really have a decision in this how to do it. This is what you get. This is how it works. Deploy it, and then you can talk to WhatsApp Cloud, right? And this solution is single tenant, right? So Facebook says, if you want to have hundreds of senders, hundreds of clients, you need to have hundreds times this, right? So our standard setup, when we first started to enable this WhatsApp communication, right, it was very easy. Oh, yeah, I just need 3 virtual machines and I install these Docker containers. What could be easier, right? And how business improved, right? And we always want the business to improve. We kind of started to build more and more virtual machines, you know. At some point, we find ourselves, we have thousands of virtual machines just for WhatsApp, right? And the worst part of it is, you know, the resources, not all the resources are used as they could be. Because when you have a virtual machine, you know, just 1 gigabyte of RAM and 1 gigabyte of disk will go to the operating system. Forget about it, right? So these thousands of virtual machines, they're just holding Linux operating system files on disk, right? So it's stupid. And we could say that RAM disk is cheap, who cares, right? But what is not cheap is the time that you need to wait for these resources to be available, because somebody needs to buy this hardware, you know, ship it to the data center, and now we can add more sender. This is just stupid. And also the deployment process of this is not very simple. So we automated everything, you know, but it really looks ugly, you know. This is a spaghetti monster, like 10 different tools, you know, just to automate something, right? And at some point we said, okay, so how would this look on Kubernetes, right? And if we used Kubernetes only for this, it would pay off, you know, nothing else, just this, it would pay off. So actually, we made it work like this. It is just one single command, right, that will spin up a sender and install it, and you don't need HA proxy, you don't need some fancy service discovery, it's all built in, you just use DNS. And it's very easy. Now you can create a one-click deployment of sender, and you can expose this button to the business itself, and they can click it. So they don't need to create task for me to do it. You know? So in the end, you know, we started rolling this WhatsApp part to Kubernetes. For now, it looks good, right? So for now, it looks good. So what are kind of our future plans, right, and next steps for the future? At the moment, we have 3 production clusters running, and we have 3 more in pipeline. Like by the end of the year, we would like to have them deployed and ready to be used, right? We have also 1 staging cluster where developers can deploy their stuff first and try it out. And we have 1 development cluster which is actually used, you know, by operating teams to test, you know, upgrade process of clusters and so on. So all of this is currently managed. We have 1 team that is managing all of this Kubernetes stuff, right? It's 4 people, right? And the biggest challenge here is, you know, the know-how you need to get for this to really be like, so that you can sleep at night, being sure that this platform, which needs to run 24/7, kind of works okay. We are onboarding teams, not all at once. You cannot do it all at once. When we started to migrate our applications to Docker, it was kind of, Docker, why I need Docker? What it brings me? Nothing. You know, to developers, it brings nothing, just more pain, you know, because you need to learn new stuff. And who wants to, I don't want to move out of my comfort zone, you know. I like Java minus jar and, you know, leave me be. And but, you know, there are benefits which are maybe not clear to development teams, but which actually help you to improve and make it easier to run your infrastructure, right? So what we want to have in the end, right, what is our goal to have, is we need to have a Kubernetes cluster on every location for it to be usable. So when we started to say in company, we are working on Kubernetes, everybody was super excited. Kubernetes, new, cool, shiny thing. So they stopped asking about Docker. Docker is not a problem. We can do Docker, right? But, you know, then they asked, okay, when can I deploy my application to Kubernetes? Because they expect everything to work the same way. So no. I cannot do it because I don't have, you know, Kubernetes everywhere, so take it easy. And this is like the first step we need to have. Right? Next thing that we want to have is like stable storage. So currently this is kind of a gray area for us, right? So we install this Ceph, we have it on every cluster, but we know the least about this, right? So if Ceph breaks, you know, I lose my partitions with the data. It's not an option, right? And hope is not a strategy. We cannot hope that this Ceph will never break because, it has multiple replicas and so on. It just breaks. And what we absolutely must have is effortless migration. So ideally, developers would wake up one morning and simply deploy their applications, and they wouldn't even know they are now running their applications on Kubernetes. So this is kind of the ideal scenario. Of course, they need to be aware, because in our company, we are using this model. You build it, you ship it, you own it. So nobody will manage your applications in production. If you wrote it, you need to manage it yourself. So developers need to have the knowledge on what kind of platform this is running, and they need to have like basic troubleshooting skills to connect to this container and start troubleshooting the applications. What we did when we kind of did the switch to Docker was that we kind of enabled this to be running side by side. So if I have 4 instances of my application, I will first deploy one of those instances to this new platform, using Docker. And then I will wait for a week. And then maybe, if everything is okay, I will deploy once more. And if everything kind of goes good, then I will maybe put 2 of my instances on Docker, and then 3, and then all of them. And then in the end, I will stop thinking about it, right? Because now I trust that Docker is a stable platform. And we need the same thing with Kubernetes. So this is what we need to do. Simply allow the developers to choose for themselves. Look, here you don't need to create virtual machines. Just put a number, like 2 instances, and click deploy, and forget about it, right? And this is what we hope for, and this is what we must have, because historically this has been proven the only way to work, in the adoption sense, right? One other thing is that we want to leverage the power of the public clouds. So every public cloud today has file new Kubernetes cluster, right? And you can create a Kubernetes cluster. So we want to leverage this power so that we can simply deploy our applications on top of, once we can deploy them on Kubernetes, we don't really care, if this is on public cloud or this is on premise. Like this is the ideal version, right? It's never really that black and white, but it is doable, right? So in the end, is all this trouble worth it, Because, and this was a question, there was some discussion that we had inside the company, and somebody asked, but look, we already have Docker, isn't the Kubernetes the same thing? Why would we now switch from the platform that we know intimately well to Kubernetes? Isn't it just a risk, right? So yes, it is a risk. Anything we do, any change we do is a risk, right? The only thing is, do we have the benefits? And we think, in the long run, this will bring us benefits. We will be able to focus more on business and less on infrastructure, because we will not be forced to reinvent all these features that come nicely with Kubernetes, auto recovery, auto scaling, whatever. We don't need to reinvent them, right? So, of course, we will have other challenges. There is no free lunch. So we will have other challenges. But we are betting, that we will need to put less effort if we go the Kubernetes line than if we continue rolling our own, right? And as we say in Infobip, we are just starting, right? So there is always room for improvement. So we hope, I hope next year, this time next year, I will kind of have a talk like how we successfully did it, or not, or maybe, we dumped the whole thing. So, thank you very, very much for your attention. This is all I got for you today.
So thank you for the talk. We're going to move on to the questions from Slido. If I can please ask to show them. Thank you very much. So we have a couple of questions. The red shirt guy in the front row is asking, did you guys at Infobip really need Kubernetes, or were you influenced by the hype train?
Yeah, so I first would like to think that we are not influenced by the hype train. But what we see is that we are constantly improving our platform and building in features. And over the fence, I already have those features. And we see, how much effort we need to put in this, in documenting this, in making it stable, and I already have those features there. So hopefully it's not a hype, right? So hopefully it's not a hype.
But it's available to you, so why not?
Yeah, it's just a tool that we would like to use to maybe, improve our business. So if this platform, on Kubernetes turns out to be not working so stable or not proving, that giving us the benefits, we'll just dump it because it's just a tool, right?
All right, so next question. In your opinion, how big or small do you have to be to consider using Kubernetes?
I would say the smaller you are, go for it, because this, this is really something. We have like more than 15 locations on which you need to maintain Kubernetes on premise, right? Okay, we already, we are maintaining our platform. Now we have this strange thing that we also need to maintain, and for a while we will need to do it in parallel, right? So I would say if you are smaller, it's easier to start. Right? And if you are as big and if you have lots of things that you need to kind of push in parallel, it gets harder, right?
All right, thank you. So we have a black shirt guy in the mid hallway now. He's asking, why don't you use Ingress instead of connecting directly?
Why? Because I don't want to. I want no ingress. Ingress means just have something else on top of it. Can I not have anything else? Can I just talk directly to my pods? The answer is yes, and so nothing is stopping us to do it, right? But why? Okay, I can have ingress, but this is just something else I need to somehow install in my cluster. And on-premise ingress is not like a totally solved problem, right? So it just was, some additional layer of complexity that we didn't know. And, we did consider a metal load balancer, and we kind of struggled with this for a while. But then we learned the power of BGP, which exists like for 50 years. And at this moment, it was very simple. So everything remains the same. We can use ingress if we have the need to. Currently, we don't have the need to.
All right, next question. What is the performance overhead you measured with Docker, Kubernetes, etc.?
Okay, so we actually tried to do it. And in terms of, we did some measurements, like running applications on Docker and outside of Docker, like normal processes, right? And we didn't measure any considerable latency increases or CPU usage problems, because it's just a normal process inside the Linux operating system. So it uses some CPU, and the overhead may come from this network layer if you are using this port mapping and this part, but this was really insignificant for us. And in terms of Docker, the overhead, there is no overhead, because Kubernetes under the hood just does the same Docker run that you would normally do, only in an automated way. You tell him, okay, I want like 4 or 5 instances, and it will, Docker run, Docker run, Docker run, Docker run, and you can have just a container running. So in terms of overhead, you have overhead of these additional like agents that are running on every virtual machines that you have, right? Which actually do those Docker run stuff. But for us, it's acceptable. How we do it now, we don't have agents. When you click deploy and this magic happens, some system goes and SSH into the machine and does Docker run. It's some script that does Docker run. So for us, not so, we didn't measure any significant like overhead.
All right, there are some people interested in learning more about this stuff, so they're asking if you can get your slides.
Okay, I can put them like on slide deck or something, or you can just talk to me now and I will send it to you.
All right, so moving on to the next question. You were talking about the good stuff, obviously, so what's the bad and ugly stuff about Kubernetes?
Yeah. So, like, there is always like bad and ugly. Bad and ugly is when you want to run some application and something that you expect it would happen, it doesn't happen, right? And then you try to understand why it doesn't happen, and then, the hole goes deeper and deeper, and under all of this pile, you find out that this is something wrong, this is some bug in Docker container runtime, and then this is the ugly part. And then you need to figure out the ways how to go about it. The ugly stuff is the question, okay, what do I need to run on these worker nodes in my Kubernetes cluster additionally, which do not come with Kubernetes so that my system will not, just stop working. Like, do I need to do Docker prune? Do I need to, check if some containers were not deleted properly? Like, what is the set of scripts I need to run inside my Kubernetes cluster to really recognize this stuff, for which there is some, bug report on GitHub, but is not yet solved. So this is the ugly stuff for me.
All right. It seems we're out of time, so thank you for answering all those questions.
Yeah, thank
now
you.
You can go talk to the 70 people that raised their hands. And just one more info before we end. So there's an after party at 8 p.m. at Horst, so don't forget about that. And thank you, Mario Žagar, again for your presentation.